Hello students, in this video I will go through U5A02A, where this is an exercise on discovering some of the properties associated with similarity transformations. So there was no official lesson, no formal lesson associated with this topic. That's because I wanted you to go and do some discovery of your own. But if you're having difficulty and you want a little more guidance, then this is the video for you then. All right. So we're going to graph triangle ABC, and then we're going to perform a series of different things, okay, to triangle ABC. So let's first plot this out. ABC. So A is 2, 1, which is located here. That's A. And then B is 6, 2, which is here. And C is located 3, 4. 3, 4 is over here, and that's C. The question here says to find the coordinates for triangle ABC after a dilation of 2. Label it as A prime, B prime, C prime. All right, let's do that. So I will draw the original as a black triangle, and then with the subsequent dilations, I want to change colors. So a dilation of 2, I want to use a blue. So we'll end up at here. This is going to be A prime. B prime will end up being at 12. So 2, 4, 6, and then 4, like right there. So that's B prime. And C prime will end up being 3, and then 4 will be right there. So this is going to be C prime. All right. Graph the image of on the same grid. All right, so I just did that, and I labeled A prime, B prime, C prime there. Okay. Find the coordinates of the. Oh, and I forgot to state the coordinates. So the coordinates of A prime is going to be 4, 2. B prime is 12, 4. And C prime is 6, 8. All right, next I will need to do a dilation of 3. So I'm going to just write it out first, I guess. So that would be 6, 3. And then B double prime would be, the original coordinate was 6, 2, so it's going to be 18, 6, and then C double prime originally was 3, 4, so it will be 9, 12. And it says find the slopes of A prime. Oh, and I got to graph this out, of course. So that means the C double prime will be over here. I'm just going to go another 3 and 4 over, so that's C double prime. And A double prime will be, I'm going to go 4, I'm going to go another 2 over and 1 up. So that's, I'm sorry, I should have used a different color. So I want to use red in this case. Okay, and I'm going to make this a little thicker. So then A double prime and B double prime will be over here. So I'm going to go another 2, 4, 6, and 2 up. So I'm going to be over here, B double prime. And then if I plot this out, I will end up over here. Hold on, I made a mistake. Yes, I did. This is not the right one. So I'm going to go 2, 4, 6, and then go 2 right there. Okay, that's it. Which was what I had before. Okay. When the graphs get larger, it gets a little more challenging to manage just because there are so many grids in between. Okay, so I have this. Now the question says, find the slopes of A, B, C. AB, BC, and AC. Okay, so the slope of AB, all I got to do is just look at this. This will be positive 1/4. The slope of BC, look at that again. The slope of BC will be negative 2/3. I'm sorry. Yes, negative 2/3. And the slope of AC will be positive 3. Then it says find the side lengths of AB, BC, and AC. So AB will be square root of, I go 4 over and 1 up, so that's square root of 17, right? 4 squared plus 1 squared. BC, I'm going to go 2 down and 3 over, right? So that's 2 squared plus 3 squared, so that's square root of 13. And AC, what will AC be? AC will be 1 over and 3 up, so that's square root of 10. 1 squared plus 3 squared. Find the perimeter of ABC. So the perimeter is square root of 17 plus square root of 13 plus square root of 10. This is the perimeter of ABC. Okay. Find the slopes of A prime B primes, A prime B prime, B prime C prime, and A prime C prime. So A prime B prime, if you look at the diagram, right, A prime B prime will have the same exact slope. I want to try to draw this a little better in blue. So I want to go from A prime to B prime. I want to go 2, 4, 1 up, and then 2, 4, and then 1 up. So actually it's the same slope. And actually if you look at this, right, all of these, okay, will have exactly the same slope as before. And then over here with the double prime, if you look at this, 1, 2, 3, and then 1, 2, 3, and then over here same thing, 1, 2, 3, right? You can see that all of these will end up having the same exact slope. When I say all of these will have the same exact slope, I mean all the corresponding sides will end up having the same slope. So the slope of AB was 1/4, right? So A prime B prime will also be 1/4. A double prime B double prime will also be 1/4. All of the corresponding sides will have the same exact slope. So if that's the case, this will be 1/4. The slope of B prime C prime will be negative 2/3. And the slope of A prime C prime will be positive 3. Find the side lengths of A prime B prime, B prime C prime, and A prime C prime. If you look at this, the diagram that is, you can already kind of tell that the side lengths are all going to be either the double or triple of the original. Just look at it using your eyes, right? Going from A to B, or actually let's do A to C because it's less congested. Going from A to C, right, we go 1 over 3 up. A prime c prime, we go 2 over and 6 up. And then from a double prime to c double prime, we go 3 over and 9 up, okay? So all of these are going to be, all the lengths are going to be multiplied by either a factor of 2 or 3. So if you look at this, what those lengths were, square root of 17, square root of 13, and square root of 10, this would be multiplied by a factor of 2. That's all it is. Find a perimeter of a prime, b prime, c prime. So that would be 2 square root of 17 plus 2 square root of 13 plus 2 square root of 10. Now I didn't specify this, but there's a common factor here of 2, isn't that right? So if that's the case, then the perimeter of the image will be double that of the perimeter of the pre-image. Find the slopes of side A double prime, B double prime, and so on and so forth. So I think I've convinced you, and if I didn't, please do go back and revisit my explanation, or come to office hours and and ask why that's the case. But all these corresponding sides will end up having the same slope. So this is going to be 1/4. B to C would be negative 2/3. And A to C would be positive 3. The side length of A double prime, B double prime. So A double prime, B double prime, B double prime, C double prime, and A double prime, A double prime. This will be, the lengths will be multiplied by 3. So it's 3 square root of 17, 3 square root of 13, and 3 square root of 10. Likewise, 3 square root of 17 plus 3 square root of 13 plus 3 square root of 10 will be the perimeter, and this will be 3 times the original, the pre-image. Find the ratio of A prime, B prime to A to B. So A prime, B prime over AB. This was dilated factor of 2, so this is going to be 2. And you don't have to take my word for it. You can also convince yourself A prime, B prime was 2 square root of 17 over square root of 17. And that was equal to 2, right? B prime, C prime over BC, that's going to be 2. A prime, C prime over AC, that also is going to be 2. And actually, you know what? I'll just write it out. Spell it out even clearer. 2 square root of 13 over square root of 13. A prime, C prime over AC. 2 square root of 10 over square root of 10. And that's again 2. What do you notice about these proportions? They equal to the scale factor. Proportions equal scale factor. What do you think the ratio of the perimeter of A prime, B prime, C prime to ABC will be? How do you know? Well, the perimeter of A prime, B prime, C prime was 2 times the pre-image. Remember that? And the perimeter of the original is this thing. So the ratios of the perimeter of the image to the pre-image will also be a factor of 2. Find the ratio of A double prime, B double prime, AB. Okay, so here, A double prime to B double prime to AB. This was 3 square root of 17 over square root of 17. B double prime, C double prime over BC. This was 3 square root of 13 over square root of 13. And A double prime, C double prime over AC. This is 3 square root of 10 over square root of 10. and these will all equal to 3. What do you notice about these proportions? So proportions equal scale factor. What do you think the ratio of the perimeter will be? How do you know? This will be by, so again, P A double prime, B double prime, C double prime to P A prime to P of the perimeter of A, B, and C. This will be 3 square root of 17, square root of 13, plus square root of 10, over square root of 17, plus square root of 13, plus square root of 10. So this is also equal to 3. Okay, so question 17, using your protractor and angle measures of A, B, and C, what do you notice about the corresponding angles? Now, I don't have a protractor here, but the conclusion is you should have come up with this, that angle A will equal to angle A prime will equal to angle A double prime. Angle B will equal to angle B prime will equal to angle B double prime. Angle C, will equal to angle C prime will equal to angle C double prime. Find the area of triangle ABC, A prime, B prime, C prime, and A double prime, B double prime, C double prime. Okay, so the areas here, okay, so the way in which I'm going to do this is I'm going to draw this thing out on another over here. And the way in which I'm going to do this is I'll do it like this, where this is 4, and this is 1, and this is 3, and this is 1, this is 3, and this is 2. Right? What am I doing here? I am stating all the horizontal and vertical components, okay, where we go from A to B, B to C, and then from C back to A. So here I can tell that this will, there are 3 right triangles, and that will be an area of 3/2. Over here, this will be an area of 3/4. This will be an area of, I'm sorry, not 3/4. What am I doing? Jeez. This will be an area of 3. Then this will be an area of 2. So if I add these right triangles up, I'm going to get 3 plus 2 plus 3/2. And I need to subtract this from the overall rectangle here, which is a 3x4 rectangle, so it's 12. So the area of triangle ABC, what will that be? That will be 12 minus 6.5, which is going to be 5.5. This is ABC. We'll have an area of 5.5. I want to do this again. This time, this will be 6, this will be 2, this will be 6, this will be 4, this will be 8, and this will be 2. Now if I do this again, this will be 6, this will be 12. When I say this, I mean the area of that right triangle there, and this will be 8. So the area, if I add up all those right triangles, I get 6 plus 12 plus 8, and I need to subtract that from 6 times 8, which is 48. 48 minus 18 plus 8 is 26. And then 26 subtracted from 48 is 22. So A prime, B prime, C prime will be 22. Okay? And I'll draw it up here, the last one. So this will be 9 by 3. And this will be 9 by 4. And then this will be 12 by 3. So if you look at this, okay, the right triangles that I have, this will be 27 halves. This will be 36 divided by 2, so that's 18. This will be 36 divided by 2, and that will be 18 again. So find out what the areas are of the right triangles. So that would be 27 halves. And what is 27 halves? That is really 13.5, right? So 13.5, 18, and 18. All of this is subtracted from 9 times 12. So this would be 108 minus 18 plus 18 is 36. 36 36 plus 13.5. What's 36 plus 13.5? So that would be 49.5. And if I subtract 108 by 49.5, I will end up with 58.5. Is that right? Yes. So A double prime, B double prime, C double prime will equal to this. And it may not be obvious at this point right now, but if I take A prime, B prime, C prime divided by ABC, I take A prime, B prime, C prime divided by ABC, I will end up with 22 over 5.5, and that will be 4, right? If I take A double prime, B double prime, C double prime, which is 58.5, and divide that by 5.5, this will turn out to be, I'm sorry, I subtracted wrong. It's not 58.5. It's 59.5, right? Is that the case? 108 minus 49.5. I'm going, I don't know why I'm struggling with that. 108 minus 49.5. 58.5. And if I divide that by 5.5, I'll end up with, hold on. So 9, 3, 12, 3, 9, 6. Oh, I made a mistake, which is why I hesitated. This should be 9 and 6. Okay, so 54 divided by that would be 27. So then one of these, this would be 27 here. And then 18 plus 27 plus 13.5, that would change the final answer here, of course. Okay, so 18 plus 27, that would be 45. 45 plus 13.5, so 18 plus 27 plus 13.5. And I will subtract that from 108. And that would be 49.5. So 58.5. and then this would be 49.5. Okay, so, and then I would take 49.5 and divide by 5.5. So if I take 49.5, divide by 5.5, I'll end up with 9. So if you look at this, right, this is the next part here is I'm asking you to summarize what you see here, okay? The scale factor. If the scale factor is 1, the side lengths will be multiplied by 1. The perimeter will be multiplied by 1. The area will be multiplied by 1. If it's 2, multiplied by factor of 2. The side lengths, the perimeter will be multiplied by a factor of 2. And the area will be multiplied by a factor of 4. Then it'll be 3, 3, and 9. And if you could make an educated guess on what will happen next is we're going to multiply by 0.5, 0.5. According to this pattern, it would be 0.25. According to this pattern, it will be 1.5, 1.5. The area will be multiplied by 1.5 squared, which is 2.25. So Sarah's parents got a new house. Sarah was given the choice of getting a new room with double the perimeter or double the area. Which one should Sarah pick? If her goal is to get a bigger room, explain. So chances are, if you end up with a bigger perimeter, if you double the perimeter, if the rooms are proportional, your area, the room will be actually 4 times what your original was. So if the room remains proportional, then doubling the perimeter will lead to 4 times the area. Whereas if you double the area, it will not lead to anything. When I say it will not lead to anything, I mean that 4 times doubling the area is nowhere in comparison to 4 times the area. Question 22. Find a ratio of lengths between AB, AC, AB. Okay, so now we're finding the ratio of lengths between those corresponding sides. So AB to AC, right? So AB was square root of 17. AB to AC. Square root of 17 and AC was square root of 10. A prime, B prime to, A prime, yes, A prime, B prime to A prime, C prime. This is 2 square root of 17 to 2 square root of 13. This is, again, going to be square root of 17 over square root of 13. And A prime, double prime, B double prime to A double prime, C double prime. This will be, again, 3 square root of 17 over 3 square root of 10. I'm sorry, I wrote 13 there. Should be 10. So it should be the same thing. This is square root of 17 over square root of 10. Are these the same kind of ratio of lengths found in questions 13 and 15? How do you characterize these ratios? These are not the same ratios. Not the same ratios. We're comparing side lengths, sides within the triangle, the same triangle, and not the corresponding triangle. and not the corresponding sides. And not the corresponding sides of two different triangles. Okay. Find a ratio of lengths between AB. So basically the same question, but this time I'm asking for a different ratio here. So AB to BC, this was square root of 17 over square root of 13. A prime B prime to B prime C prime. This is 2 square root of 17 over 2 square root of 13. And this is again square root of 17 over square root of 13. And A double prime, B double prime to B double prime, C double prime. 3 square root of 17 over 3 square root of 10. 3 square root of 13. Which is again square root of 17 over square root of 13. So it's the same explanation as before. Same explanation as before. As previous question. Okay. Next, number 24. Find a ratio of lengths between AC, BC. So same question. AC is 3. And BC is, what was BC? It was square root of 13. Is AC to BC. A prime C prime to B prime C prime. This is 6 over, I'm sorry, not 6. What am I doing? AC is square root of 10. So this is 2 square root of 10 over 2 square root of 13, which is again square root of 10 over square root of 13. And A double prime C double prime over B double prime C double prime. This is again square root of 10 over square root of 13. So same explanation as question 22. Question 22. And if you look at this chart here, this is actually a summary of all the conclusions that came out of this exercise. This is a summary of everything that we had just discovered together. That if we compare side lengths within the triangle, right, within the same triangle, all those ratios will be preserved. If you compare all these side lengths in corresponding similar triangles, they will be they will equal to the scale factor. If you take two figures and dilate them, the side lengths will be multiplied by k, perimeter will be multiplied by k, but the area will be multiplied by a factor of k squared. So this is the summary of everything that we've talked about in this exercise.